find the proper domain. So we're going to take a look back at what we did with lesson 1 and just find the domain of each piece. So if we want to find the domain of this left segment, so this blue one, again, domains all the x values. What x value are we starting at? -6. We're going to write it in, sorry, jump ahead. We're actually going to write an equation of the line for that segment. I thought it was domain first. So if we look to write this equation of a line, we're going to write them if they're linear lines. What's the equation for a linear line? Y equals m b. So we need two things. We need our slope and we need the y-intercept. Okay? Well, if we don't look, we can easily find the slope. You just count up and over. How far do we go up? 3. So 3 over 3. So we go 1, 2, 3. Well, what is 3 over 3? 1. So we know for this blue equation, we have 1x. We now need to figure out what the y-intercept is. The problem is we only have a piece of that line. It's not going through the y-axis at all. So we can't just visually look at it and find our y-intercept. But what did we just find? We just found the what? The slope. Well, just extend your line. Start at this point, go up 1 over 1, up 1 over 1, up 1 over 1. What's our y-intercept? 7. We found the equation of the line. So if your piece is not going through that y-axis and you need to find your y-intercept, find the slope first by just counting up and over. Reduce it. You have to reduce your fractions. And then once you know your slope, you just keep extending your line. And once you hit the y-axis, you have your y-intercept. Okay. Do the same thing for the red line or your middle line. We need our M and we need our B. Well, do we count up at all? We rise. No. So what's our top of our fraction going to be? 0. And then if our run is 1, 2, 3, 4, 5, 6, 7, to the next point, what's 0 over 7? 0. Whenever you have a horizontal line like that, your slope is always 0. If you're not rising, it's just a straight line, your slope is 0. Okay. What's our y-intercept? This one's nice where it's crossing the y-axis. So if we were to write this equation, it would technically be y equals 0x plus 2. But 0 times anything is what? 0. So it kind of cancels out, and our line of our equation is actually just y equals. So when you have that horizontal line like that, it's just y equals whatever the y-intercept is. Y equals 2. And then our last equation, the green one, again, find your slope first, our M and our B. If we count up, 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3, 4. What does that reduce down to? What's 8 over 4? I just like to pick the endpoints because I know there are those distinct points. Sometimes with these graphs, it's hard to tell if it is a distinct point, if it's in the middle, because they're small or a little blurry. So that's why I just like to use the endpoints. I know they're there. I know what those points are. They're more defined. Some of you could have been like, why did this go up 2 over 1? Let's go to 2. That's fine. I just like using the endpoints because they're noticeable. And they're usually on an exact value. So we know our slope is 2. We have to find our y-intercept. How are we going to do that? slope. So we're going to go up 2 over 1, up 2 over 1, oh boy. We go up 2 over 1, up 2 over 1. We finally hit this y-intercept. So our slope, if we kind of have to estimate, is 1, 2, 3, 4. We'll do 14. So when that happens, you just kind of have to estimate. Extend the graph. Which one would be negative? Oh. Negative 4. Why did I put 2? Will be negative. Yeah, negative 4. And then our slope would be negative 2. Yep, we went up and then left. So that means that 4 is supposed to be negative. 8 over negative 4 reduces down to negative 2. So that would be a negative 2. Make sure you're paying attention to that. Question. And you just find your slope when you're writing the equation. Find the slope. Once you have the slope, extend your line using the slope so you hit the y-axis. If it goes off the graph, you just kind of have to extend the graph, make your own little marks. Okay. Now what we're going to do is we're going to find the domains. Now we're going to find the domains of these segments. So if we look, what at the blue line, what x value do we start at? Negative 6. So we're going to write it in this notation, because that's how it is in the piecewise problem. Do we need a line underneath this inequality? Yeah, why? Yeah, close point at negative 6. So the inequality at negative 6 needs to have a line underneath it. We follow the blue line. What x value does it end at? 3. Do we need a line underneath that inequality? Why? Open circle, no line. There's that domain. Now find the domain of the red line. Which x value do we start at? -3. Do we need a line underneath our inequality at -3? Why? Good. This one is dot. What x value do we end at? What x value do we end at? 4. Do we need a line underneath our inequality at 4? No. Open point. Don't need a line. And then our last one, this green one's kind of hard to see. What x value do we start at? 4. Do we need a line underneath it at 4? Yep. Close that. We need a line. And what x value do we end at? Do we need a line underneath our inequality at 8? It's an open point. You have to make sure you pay attention to those inequalities. Put a line underneath it if it's a closed point. No line if it's open. Well, there we go. We pretty much have all the information we need to write a rule for this function. You just take the equation of the blue line. You don't need the y. You just need this part. The y is already there with the f of x. We said f of x is fancy for y. So we're just going to say x plus 7. Write the first equation. Then you're going to put a comma, and right next to it, you're going to write the domain. So then you're going to write the domain of that blue line. Take the equation, and again, you don't need the y, you just need this part of it, of the red line. And then you just write the domain. And then lastly, you take the equation of the green line. Don't have the y. The y is already represented there. -2x plus 14, comma, the domain. Done. So you just need to find the equations of the lines, find the domains of those lines, and then fill it in the brackets with the equation matched up with the right domain. Go from left furthest left equation, middle furthest right. Questions over there? I know. Okay. So the left portion of our graph, these are supposed to have arrows on the end. So it's arrows on the end. What do you notice is different about these two parts of our graph than the first one? What's different about these two pieces and the three pieces we had here? We have what? Yeah, they have arrows. Okay, so how many defined endpoints do we have in each line if they have arrows? One. Okay, here they were segments, so we had two defined endpoints. So we had two defined domain values. We only have one defined endpoint, so we're only going to have one defined domain value. Okay? Keep that in mind. So let's write the equation of the most left line first. So find the slope. You count rise over run. What does our slope end up being? If you did that, we rise, we go up 2, you're right, over 1. So it would just be 2 over 1. So our m is 2 over 1, which is just 2. Once you have your slope, extend it. Go up 2 over 1. What's our y-intercept? Is everyone okay with that part? Just like you did in Algebra 1, you pick 2 points on the line, count up, and then over. Reduce your fraction, you have your slope. Once you have your slope, if you need to, extend your line, you have your y-intercept. Okay. So what's that equation going to look like if we want to write it in y equals mx plus b form? What's it going to look like? Yeah, y equals mx. Okay. If we go, let me erase this here, and find the domain of this, technically, what x value do we start at? Negative infinity. What x value are we ending at? 1. Negative 1. When that happens, remember when you only have one defined endpoint, it's just a single inequality. Okay? So I'm going to say x. We know our one defined endpoint is negative 1, and it's going towards negative infinity. So is this going to be less than or greater than? Less than, because it's going smaller than negative 1, so it's going to be less than. Do we need a line underneath that inequality? No. Why? Open circle. So there you go. There's the domain of that one. Okay. Do the same thing with the other line. Find your slope. Find your b. What is our slope of this second line? 1 over 1. So, 2 points. Up 1, over 1. And try to do endpoints. Sometimes it doesn't work out when you have errors. Yes? Negative 1 over 1. So we went up and to the left, so it will be negative. From there. What's our y-intercept? Nice and easy. So what would the equation of this line be? Y negative x plus 3. If you did negative 1, x plus 3. Here we have to figure out our domain. Well, we know we only have one defined endpoint. What is the defined endpoint of that line? Of the So one defined endpoint. -1. And it's going towards what? Positive infinity. So all the numbers that are bigger than -1. So it's going to be greater than or less than? Greater than. Do we need a line underneath it? Yep. Close point. Give you a little hint with these. Generally, these numbers are the same. And generally, these are going to go in the opposite direction. Majority of the time, one's not going to, if one doesn't have a line, the other one has to. Majority. Sometimes it doesn't work out that way, but we'll see. Okay? And then you just fill it in. So you just, again, do we want to include the y here? We want to write it like this. Is this correct? No. That's already written there for you. Don't do that. That means y. So you just need the other part of it. You need the x part. 2x plus 3, comma, write the domain. Then write your other equation again. We just need the x part, comma, write the domain. So. Questions over that? Then you just find the slope. Once you have the slope, extend the line if you need to get the y-intercept. Write the equation, find the domain, write them together. And those graphs. Make sure you always go for the furthest piece first and the most right piece second. Questions? Alright, exercise is yours.